All right, welcome. Thanks for joining for this optional video. Just a reminder, as you're working through here, you can feel free to do these problems on your own. Try and do them on your own. Pause, skip, go ahead. This video does allow you to skip in case you're not aware. And, use this one as you please. Go back, rewind, ignore me, whatever. But sometimes my explanations are pretty good, so you may, if you get something wrong, want to hear all of what I'm saying. So find the vertex and sketch a graph of f of x equals x squared plus 2x plus 1. What you want to do here is put this into vertex form. Vertex form is a lot better because I can see the vertex right away. I can see the direction of the parabola, and I can see if there's any stretching or shrinking. So looking at this trinomial, something that you should notice is that it can be factored. And more specifically, it's not just that it can be factored, it's that it can be factored in a way that is going to put this into vertex form. So if I factor this, it becomes f of x equals x plus 1 squared. You're thinking about numbers that multiply to 1 and add up to 2. So this becomes x plus 1 times x plus 1, which is the same thing as x plus 1 squared. This right here is vertex form. So remember that vertex form, what that would call for, let me just find the color real quick, there we go, is a times x minus h squared plus k. So based upon that, the vertex is h comma k. So h is what did I just subtract from x? So sometimes people get confused because they look at this and they say, okay, h is 1. It's the opposite of that. So it's actually going to be negative 1. Because it has to be what did I subtract from x? Well, I didn't subtract 1, I subtracted negative 1, and subtracting negative is what gave me a positive. K, since there's nothing here, is 0. It says to also sketch this, always making sure that we read those instructions. So if I'm sketching this, at negative 1, 0, I have the vertex. Because A is positive, and is just 1. This hasn't been stretched or shrunk or anything like that, but I have some graph where A is positive and my vertex is at negative 1, 0. I sort of missed a little bit on that vertex, but it's a sketch and it doesn't have to be perfect, I guess. All right, more examples. Find the vertex and sketch the graph of 2x squared plus 8x plus 7. So notice this cannot be factored. So what we're going to have to do is do this in just a different way. That way that we do this is by completing the square. And this is where I'll sort of walk through how do we complete the square. So completing the square over here, we have 2x squared plus 8x plus 7. The first thing that you need to do when you complete the square is ensure that your lead term has a coefficient of 1 x squared. It doesn't right now, so I need to divide out this 2. However, I only divide it out from the first 2 terms. What I do then is I push this positive 7 over here, and I say, okay, I'm going to complete the square, which is going to call for me to add something. And because I have to balance out this expression, I can't just like throw something into an expression and expect that it didn't just change. So I have to balance this out by subtracting on the outside. So my process for completing the square, what goes inside this blank is b over 2 squared. So I take this middle term, 4, that's my b value. So I have 4 over 2, which is 2, and then I square it. So this becomes 4. In a lot of cases when you complete the square, now people will look and they'll say, okay, I just threw a 4 in this expression, so I have to balance it out by taking out a 4. But this 4 is being multiplied by 2. So this is actually like a 2 times 4. So this is really sort of like an 8. So to balance this, I take out 8. Completing the square allows me to now write this as a perfect square trinomial. Sort of like this previous problem where I was able to write it as x plus 1 squared. Completing the square gives me a trinomial that's going to guarantee that I can write it like this. So now I get x plus 2 squared. The 2 squared would give me 4, and the 2x times 2x would give me 4x. 7 minus 8 is negative 1. Now, this is in vertex form. You can see here I have a times x minus h squared plus k. Based upon that then, h must be a negative 2. Again, that minus a negative is what gave me a positive 2. And k is just negative 1. If I'm sketching this then, at negative 2, negative 1, I have my vertex. A is positive, so I'm opening upwards. And it has sort of been vertically, well, not sort of, it has been vertically stretched. This multiplication by 2 here tells me that it's just a little bit more narrow, which you're not exactly going to see, but we'll draw it like that. So there we have our vertex at negative 2, negative 1. We just went over how to complete the square, and we'll get a little bit or a lot more practice with that. So find the vertex and sketch a graph of negative x squared plus x minus 30. Notice again that this cannot be factored, so we are going to have to complete the square. I'll do this over here. I have negative x squared plus x plus blank. Now, we have to be a little bit careful. This negative was already factored out of this whole thing. So if I'm now taking the 30 and pushing it over here, this 30 is really a positive 30. This negative times negative is a positive 30. And I just pulled it out of that parentheses. I'm going to have to balance this equation by saying minus blank. How do I get what goes in this blank? I do b over 2 squared. So here, b over 2, b is 1. So this becomes 1 over 2 squared. 1 over 2 squared, in order to square this, I do 1 squared, which is 1, 2 squared, which is 4. So this becomes 1/4. Then we think about what is the actual value of this. Well, this is 1/4 times negative 1. So this is really negative 1/4. So I just threw negative 1/4 into this expression. So to balance it out and make it still the same thing, I have to add 1/4 on the outside. If I don't do that, I'm saying that I had like x plus 2 and just adding another 10 into it and being like, oh, so x plus 12, whatever, same thing. No, I'm just trying to rewrite this, but have the value remain the same. All right, so we'll have negative. This becomes x plus 1/2. And you'll notice whatever you had right here is going to come down here, squared. And then 30 plus 1/4, thinking about that, 30 over 1 plus 1/4, you get a common denominator. So this is 120 fourths plus 1/4. So we get plus 121 fourths. I am going to recommend right now, f of x equals. I am going to recommend now that you try and do this with fractions. I know you hate fractions. I get it. I really do. But the decimals are going to be a lot tougher for you to use. Even if you feel like in certain cases they're nice, like here it's 0.5, here it would have been 30.25, and you're thinking, oh, that's nice, that's easy. But what we do later on, really you're gonna want the fraction. So just get into the habit of doing it now. I wouldn't steer you wrong. Vertex. Here our vertex, it's the opposite of what I have here, so negative 1/2. And then it's exactly what I have here, 121 fourths. The sketch for this, I go to negative 1/2, positive 121 fourths, which I'll just call 121 fourths. I'll call this negative 1. And then the one thing I do want to keep in mind is that because there's a negative here, this is opening downward. All right, moving along. Find the x-intercepts of this, and now graph it and sketch it to graph based off of x-intercepts. So this is a different type of thing. I'm not looking for the vertex. If I'm looking for the x-intercepts, what I want to do is factor this down. So if I'm going to factor this, I'll pull the negative out. I get x squared minus 6x plus 8. And then I'm doing trinomial factoring here. So I get negative. You're thinking about numbers that multiply to 8 and add up to negative 6, which would be negative 4 and negative 2, x and x. Negative 4 times negative 2 gives me positive 8. Negative 4 plus negative 2 gives me negative 6. When we're talking about x-intercepts, we're talking about setting this equal to 0. And now we're able to take these two terms and set them equal to 0 separately. Here I get x equals 2. Here I get x equals 4, which means 4, 0, and 2, 0 would be my x-intercepts. If I graph this, 1, 2, 0, 3, 4, 0. This is a negative for our a value, which means that this is opening downward. Don't know what the vertex is because I didn't complete the square or factor that in a way that it gives me vertex form, but I used the x-intercepts instead to give me an idea of how this looks. All right, some different types of questions then. Write the equation of a parabola with a vertex of 4, negative 1 that passes through 2, 3. So what we're going to do is use the vertex form. So we're going to use f of x equals a times x minus h squared plus k. When it gives me a vertex of 4, negative 1, that's giving me h and k. And it passes through 2, 3. Well, this is a point on this function. So this is an x and a y value. And think about y again, that means f of x. So I have h, k, x, and f of x. So 3 equals, I don't know a. I do know x is 2. Minus, I do know that h is 4 squared, and I know that k is negative 1. So what I'm solving for here is a. I get 3 is equal to a times, this is negative 2 squared, which is 4, minus 1. I'll add my 1. So I get 4 equals 4a. So a equals 1. This is not the final answer. I'm not going to box it off. I'm just going to underline it. It's not my final answer. It's what I use to now go back to the original equation and substitute in. So originally, we don't usually replace f of x. We leave it as f of x equals a is 1, so I don't actually have to write it. X is supposed to be a variable. This is saying the function depends on what I put in for x, so I leave it as x. And what I do put in is h and k, so minus 4 squared minus 1. If I had gotten something different for a, let's say I got 7 or negative 3, that would go in front of these parentheses. Sketch the graph. If I'm sketching this, 4, negative 1, right here. 2, 3, right here. And having this be a positive a value tells me that this parabola must be opening upwards. And I did that really poorly, so I'll try it this way. So there we go, I have a parabola opening up, going through 2, 3, and 4, negative 1. And, well, yeah, I already said opening up. Just a different type of question using that same sort of skill. All right, 2 more slides, you guys are doing great. Write the following equation in standard or vertex form. So looking at this, it's not factorable. So what we're going to have to do is complete the square on it. Again, I'll complete the square over here. x squared plus 10x plus blank plus 14 minus blank. I get that blank by doing half of 10, which is 5, squared, so 25. The actual value of this 25 is 25. It's not being multiplied by anything. So I just threw a 25 in, I balance it by taking a 25 out. This becomes x plus 5 squared minus 11. So my vertex, I don't know why there's 3 dots there, my vertex is going to be the opposite of this, negative 5, and then negative 11. I do know then that this should be opening upwards because A is positive. If I sketch a graph, negative 5, I think that's 11. So I'm at negative 5, negative 11, and I have a parabola that's opening up. All right, great. And then last type of question, find the x-intercepts if I have x minus 6 squared minus 3. So for one, I know the vertex is going to be 6, negative 3, but it asks me for the x-intercepts. This just can sort of help me with the sketch. So looking at my x-intercepts, what I do with an x-intercept is set this equal to 0 and then solve. So I add 3. I square root both sides. When you square root while solving, please remember that you get positive or negative square root 3. And this is where my 2 x-intercepts are going to come from, one being a plus, one being a minus. I add 6. So this is x equals 6 plus or minus square root 3. If I had 6, plus square root 3, comma 0. If I did 6 plus square root 3, what that gives me in my calculator is approximately 7.73. My other x-intercept is 6 minus square root 3, comma 0. And again, in my calculator, that comes out to about 4.27, comma 0. This is the exact value, 6 plus root 3, 6 minus root 3. Those are exact. 7.73, 4.27, those are approximations, but they're useful for the graphing because I don't know what 6 plus square root 3 is. So if I'm going to sketch this now, I go to approximately 4.27 and put a point, and approximately 7.73 and put a point. My vertex I know is at 6, negative 3, and I have a parabola that's opening up in between these. Having the idea of the vertex, still sort of helps me here. I knew it was supposed to be opening up, and I can see logically, okay, I get this is like sort of right in the middle of these 2 points, which is a good thing. It should be for a parabola. All right, some of the algebra there, just a little bit weird. Most of you guys are pretty fine with factoring, but just keep in mind if you need to go back and hear that explanation of completing the square again, feel free to do so. I walk through it a little bit quickly, but that's because you can hear it as many times as you want to hear it. And you can pause, slow me down, fast forward. Okay. See you tomorrow in class. Good luck. Get started on the homework.